Here we have an equilateral triangle and a parallelogram. Various lines represent various vectors. We're told the magnitude of vector P is 3. That's represented by the line AB, one of the sides of this equilateral triangle. So the length of AB will be 3, as will the other two sides on this equilateral triangle. Now remember, the angles in an equilateral triangle are all 60 degrees. So we've got lengths of 3 for each of these sides and an angle of 60 in there. And we're told angle ABC is 90 degrees. So part A, let's have a look at this. Evaluate P dot Q plus R. This is the dot product, scalar product, and it obeys the rule that allows you to get rid of brackets and multiply out brackets, just like real numbers. So this would be P dot Q plus P dot R. So what does P dot Q mean? Remember that if you have two vectors, A and B, with an angle theta between them, then the definition of A dot B is length of A times the length of B times the cosine of the angle between them. That's given to you in your formula sheet. So in this case, length of P times length of Q times the cosine of the angle between P and Q, that's 60 degrees, plus length of P times length of R times the cosine of the angle between P and R. Now the angle between P and R, if we shifted this R down to here, same direction and same distance, then you can see we've got a right angle here, and therefore the angle between P and R is 90 degrees. Incidentally, this angle in there would be 30. So that's 90 degrees. Now we've said that the length of P is 3, the length of Q is also 3, cosine of 60 is 1/2. You can get that on your calculator, or take a equilateral triangle of side 2, chop it in half, that'd be side 1. This angle is 60. The cosine of 60 is adjacent over hypotenuse, that's 1/2. So exact value for cos 60 is 1/2. Now in this second product of three numbers, the cosine of 90, there's a quick sketch of the cosine graph, the cosine of 90 degrees would be 0. So it doesn't matter what these two lengths are, a length times 0, the whole thing will come to 0. So we get 3 times 3 is 9 times 1/2, 9 halves, 4.5, 4.5. So that's answer to part A. Let's now move on to part B. We're asked to express EC, that's the diagonal in this parallelogram, that journey from E to C. We're asked to express that in terms of P, Q and R. So we need to go a different route. And what we'll do is, instead of going direct from E to C, let's go from E down to A, and then from A to B, and then from B up to where we're after C. So E to A, followed by A to B, followed by B to C. And what does all that represent in terms of vectors? Well, we know that E to A, well, travelling here, ouch, we went against the arrow, that's a negative experience. So it'll be negative Q, not positive Q. So if you go against the arrow, negative. So EA represents negative Q, AB You're going with the arrow this time. Very positive experience. So P represents P. And then finally this line up here, which is the same distance and same direction as this journey R from E to D. So that also represents the vector R. So that's what EC represents. It represents negative Q plus P plus R. So let's move into the last part of this question. We're told that AE dot EC is equal to 9 lots of root 3 minus 9 halves. And we're asked to find the magnitude of R. So let's just see what we know about these two journeys. Travelling from A to E, well, that represents Q. And what about travelling from E to C? Well, that's part B that we've just worked out. Usually questions that have several parts like this, the last part would depend on the previous parts. So let's just replace journey from E to C by what we found it represented in terms of vectors. It's negative Q plus P plus R. And we know that's 9 root 3 minus 9 over 2. And again, just as we did in part A, we can multiply out the brackets. So we'll get Q dot negative Q plus Q dot P plus Q dot R, which comes to 9 root 3 minus 9 over 2, we're told. Now let's look at the dot product Q dot negative Q. If we think of Q and negative Q goes in the opposite direction, the angle between these two is 180 degrees. And the lengths of each of these, well, we know they're 3. Each side in this triangle is 3. So this will have length 3 and this will have length 3. So length times cosine of angle between them will give us a 3 times a 3 times the cosine of 180. Q dot P, that'll be exactly the same as P dot Q. Doesn't matter which order you do the dot product in. And we know that's 3 times 3 times a half. That's 9 over 2. So we can replace that by 9 over 2. And the final dot product Q dot R, since we're asked to find the magnitude of R, we'll maybe just use the definition here and say, well, that's the length of Q, which we know is 3, times the length of R times the cosine of the angle between Q and R. Well, the angle between Q and R is there. It's 30 degrees. And all of that will come to 9 root 3 minus 9 over 2. 3 times 3 times cos 180. The cosine of 180, negative 1. So 3 threes are 9 times negative 1. That'll give us a negative 9 plus 9 over 2 plus 3 lots of the magnitude of R. Cosine of 30, let's go back up to this diagram. 30 will appear up here, and Pythagoras would tell us that this side is root 3. 2 squared is 4 minus 1 squared 1. 4 minus 1 is 3, root 3. Cosine of 30, root 3 upon 2. That's the exact value of cos 30. And exact values are needed here. And that all comes to 9 root 3 minus 9 over 2. Now negative 9 plus 4.5 is negative 4.5. But we have a negative 4.5 over on the right hand side here. So if we add 4.5 to both sides, these constants will disappear. and we're left with 3 magnitude root r root 3 over 2 equals 9 root 3. Now, there's various things we can do here. If we double both sides, get rid of that fraction, we'll get 18 root 3. If we now divide both sides by root 3 and divide both sides by 3, we'll finally get the magnitude of r equals 18 divided by 3, which is 6.